In this chapter, we are going to talk about the layer 1 of the OSI model, that is the physical layer. Welcome to the world of connectivity. Welcome to CCNA 200-301, Implementing and Administering Cisco Solutions, Chapter number 23, Physical Layer. Learn CCNA with Irash Academy. I have placed the complete CCNA playlist at the top right corner of the video information bar. In this chapter, we are going to discuss about the physical layer of the OSI model, different types of connectivity, copper cable connectivity, fiber optic connectivity, and finally the wireless connectivity. So what is the physical layer? Before we start talking about the physical layer, we need to discuss the comparison between the OSI model and TCP/IP model based on the lower bottom layers. So in the screen, left side you can see the OSI model and right side you can see the TCP/IP model. The OSI model has 7 layers and TCP/IP model has only 4 layers. So if you are looking at the bottom layers, the TCP/IP model has the layer 1, which is the network access layer. But in OSI model, this single bottom layer is divided into 2 layers, which is the data link layer and the physical layer. So in TCP/IP model, the functions of physical and data link layer are considered as part of the network access layer. But the OSI model provide a detailed explanation of all the network function. So they divided the network access layer into 2 layers, that is a physical and data link layer. Now we have discussed in our last chapter about the data link layer. So in this chapter we are going to talk about the physical layer. So what is the physical layer? The physical layer in the OSI model control how the data is transferred over the physical medium in a network channel. Here we need to talk about the physical medium in a network channel. We know that for the data transfer between 2 devices, we need a physical medium. For example, in a network, how we are going to connect the devices together? The first thing in our mind is cables. If you want to connect any device into a network, we should use one cable. So cable is considered as a physical medium for the data transfer. The physical layer, it is consist of various network components such as power, plug, connectors, receivers, cable type, etc. So when we talk about the physical medium, it's not only the cable, how the cable is going to terminate into the network devices. We need some power plugs, connectors, receivers, and maybe jacks, etc. So these components also coming under the physical layer. The physical layer send data bits from one device to another device. It is also responsible for converting the data frames received from the data link layer into the data bits of ones and zeros for the transmission over the network. In network layer, the data is called as packet, and when this data move to the data link layer, it is called as a frame. So these frames from the data link layer received by the physical layer, and it is converting that data into zeros and ones, and it transmit over the network. So here the physical layer is mainly dealing with the physical medium for the data transfer, and we know most common used physical medium is the cables. So how the data is passing through the cable? So what is flowing through the cable? Cables are using the electric signal for data transfer. So in that electric signal, there is only 2 types of signal, ones and zeros. Physical layer is mainly dealing with the physical connectivity between the network devices. To create a network, we need to connect all the devices in that network into a central connection center, which can be a network switch or network hub or router, anything like that. So in the physical layer, there are 2 types of connections we are using. The one is the physical connection and the second one is wireless connection. These are the 2 types of connections managed by the physical layer. We know we can create a network by using the cables, and that is a wired network, and we can create the network by using the wireless signal, that is called the wireless network, and we can create a network by mixing the physical and wireless connection together. Now let's discuss about the types of the physical connections used in a network. So in this screen you can see a network which contains 2 computers and a network switch. Here the function of the network switch is provide the connectivity between these 2 computers. It is working as a centralized connection center. This is a physical connection. So here, how we are going to create a connection between the network devices. What kind of components we can use? One is the copper cable, which is using the electrical signal. Here we can use the copper cable to create a connection between the PC and the switch. And the data will be passing through this copper cable in the form of electrical signal. The second option is using the fiber cables. The fiber cables are using the light signal instead of the electrical signal. So that means we can use a fiber optic cable to create the network connection between two devices. And data will be passing through this fiber optic cable in the form of light signal. Now let's talk about the copper cables. In the screen you can see two computers. We want to create a connection in between them. So how we can use a copper cable to create a connection between them? So these network devices here we consider as a PC. Whether it is PC or any other network devices, I mean the standard network devices, they will have the Ethernet port in it. This is also called the LAN port or the network port. So we can use the copper cable and connect at the LAN port of each computer so that they can communicate together. Copper cable is also called twisted pair cable. The copper cable contains multiple wires in twisted form. So there are 8 cables available in a standard network cable, and which has a color code also to identify the cables. So normally they are orange white, orange, green white, blue, blue white, green, brown white, and brown. These color codes are used to identify each cables. Based on this color code, there are multiple types of cable connection is available. The copper cables are available in multiple types such as Cat5, Cat6, etc. Each has their unique features. So in this copper cable, how the data is transferring from one device to another device? In the form of electrical signal. So the data from the sender, it is going to receiver in the form of electrical signal, and these electrical signals are converted into zeros and ones. We know that the computer is an electronic device which is using the digital electronics technology, and it can understand the data in the form of zeros and ones only. So it is very much necessary to convert this data that is coming from the form of electrical signals into the digital electronic signal, that is zeros and ones. And when the receiver receives this data, which is in the form of these zeros and ones, they can understand the data very well because they are the electronic devices. Now let's see on what manner these electrical signals are converted into zeros and ones. For that we need to show you a graph as shown in this picture. This is a graph based on the time and voltage. The horizontal line is time and vertical line is voltage. So consider the voltage passing through the copper cable is 5 volt, which is mentioned here. So in this graph we can see at a specific interval the voltage is 5 volt, that denote the number 1, and at some other specific point here the voltage is 0, that denote the number 0, and again another time interval here the voltage is again 5, so that denote 1. Next interval here the voltage is 0, that denote 0. So in this way, for each positive voltage it is considered as a 1 and each 0 voltage is considered as a 0. And when the voltage fluctuates between +5 and 0, it creates the data in the form of zeros and ones. So for each data, the computer sent electrical signal in many variation, and at the receiver side, they get the data. So this is a computer to computer language. Sender convert that electrical signal into zeros and ones, and receiver receive the zeros and one, and it can understand what is the data it received from the sender. Now let's talk about the fiber optic cables. The fiber optic cables are mainly using to create the connectivity between the network devices such as switches. They can use in PCs, no problem at all. The PC should have the interface that support the fiber optic cable connection. Mostly in the computer network, the fiber optic cables are using create the connection between the network devices. So how the fiber optic cables are connected between these network devices? Here let's talk about the network switches. How we can create a connection in between two network switches, which is showing the screen. In network switch, there are special interface which is called the SFP interface. So these are the SFP interface in the switch. Why they are so special? Because they are used to connect the SFP module. So what is the SFP module? SFP stands for small form factor pluggable interface, which is look like this. in the screen. So this is the SFP module that we are going to insert into the SFP interface. This module has a sender and receiver circuit which can be used to send and receive the light signal. So here how we are going to connect two network switches. That is with the help of a fiber optic cable. The fiber optic cable are special kind of cable that is designed to insert into an SFP module. It cannot connect to the normal network interface or LAN interface. It's need an SFP module which has a sender and receiver circuit to send and receive the light signal. So first we are going to insert the SFP into the SFP interface of the network switch. Then we are going to connect the fiber optic cable directly to the SFP module. So the data will be transferring in the form of light signal. In copper cable it was in the form of electrical signal, but in the fiber optic cable it is in the form of light signal. And the SFP at the receiver side receive this light signal and it can understand what data it received. So same like copper cable, here the light signals are converted into zeros and ones so that the receiver side network device can understand and read the data very well. So same like in copper cable, the fiber optic cable also convert the light signal into zeros and ones. So at the receiver side, that device can understand what data is coming in the form of light signal because it is converted into zeros and ones. Now let's talk about the wireless connection. So in the wireless connection, there is no physical connectivity between the network devices. Instead, they are using radio frequencies. So in this wireless network, there should be one device which is allowing the other wireless network devices into that network, which is called a wireless router or wireless access point. That is the one sending these radio frequencies. And on the other side, these wireless devices, they should have a wireless adapter that can be used to send and receive the data. So based on the radio frequencies, there are multiple types of wireless networks are available, like 2G, 5G. So in the wireless network, a network device broadcasts the wireless signals and the receiving device receive it through their wireless adapter. Now let's do a comparison between different kind of connectivity. So the first one is twisted pair copper cable, and it is using the electricity to send and receive the data, and the maximum distance that is supported is 330 feet. That means less than 100 meter, and maximum bandwidth it is supported is 1 Gbps. That means by using the twisted pair copper cable, we can send the maximum data with a bandwidth of 1 gigabyte per second. And the major problem available with the twisted pair copper cable is it causes interference because it is using the electrical signal. So we know that when electricity is passing through a metal conductor, magnetic loops are formed which causes the interference. And when we go to the fiber optic cable, they are using the light signal for sending and receiving the data. And the approximate distance that a fiber optic cable support is 50 miles. And they are using a bandwidth of 26 terabyte per second. One of the disadvantage of fiber optic cable are they are very expensive. Now let's talk about the wireless. Wireless are using radio frequencies to send and receive the data, and the approximate distance supported by the wireless network is 10 feet. This is an approximate value, and nowadays there are wireless devices available that provide more distance coverage. By using wireless, we can send approximately 1.3 gigabyte per second data bandwidth. And one of the issue exists with wireless is they are slower in reality. Compared to the physical connectivity, wireless is very slow. So these are the comparison between different types of network connectivity. So in this chapter, we have discussed about the physical layer of the OSI model. Then the different type of cable connectivity, copper cable connectivity, fiber optic connectivity, and finally the wireless connectivity. Thank you very much for watching, and subscribe to the channel for more videos.